area under a curve, between the curve and the x-axis, by making so many rectangles. It depends on whether the rectangle, you're looking at the left edge, the right edge, or the middle of the rectangle, the midpoint. All those called Riemann sums. We realized yesterday, hey, the more rectangles I can get, the closer to the true number when I'm approximating with Riemann sums, the better it is. The problem is, if I have a lot of rectangles, it takes me forever to do it, right? I mean, 4 rectangles isn't very many, but we did more, it took longer. Okay, we're going to look at another problem today that might be similar to this. We're going to want to find the distance traveled by an object during a certain period of time if I know the velocity, if I know the speed of the object. If that speed or velocity remains the same, then the distance problem is pretty easy, because distance is velocity times time. How fast are you going? How long are you going at speed? It'll tell you how far you went, right? Think of miles per hour, right? You're going 60 miles per hour for how long? 2 hours? I bet you went 120 miles. Pretty easy. What if the velocity isn't the same?
Then it's like a graph.
It might be
Then we
like a
go
graph.
like a Riemann sum.
Yes. So we look at example number 2 here. Where's number 2? There's number 2. Okay. Suppose the odometer on a car is broken. We want to estimate the distance driven over a 30-second time interval. So I got somebody sitting next to me who can take these readings. Assume we take speedometer readings every 5 seconds and record them as follows. Okay, so you see that when we start, I'm going 70 miles per hour, 5 seconds later, 21 miles per hour, 10 seconds, 15 seconds, 20 seconds, 25 seconds, 30 seconds later, I'm going 28 miles per hour. Right. Now, I've already done this for you. What is that in feet per second? I already converted the miles per hour to feet per second.
Wow, that's kind of fabulous.
Estimate the distance traveled. Oh, okay. Well, yesterday, estimating, I used a bunch of rectangles. Whoop, kind of want, well, let's see. I don't have room to work here. Actually, where's one? Okay. Hey, what if I use the left side? Well, first of all, what's the width of each? If you were gonna graph this, don't we usually put the time on the bottom? And we put velocity or speed over here.
Yes.
Okay. So it looks like my time, 0, 5, 10, 15, 20. Does it look like my intervals are the same? Yeah, 5. So I would argue like yesterday, hey, my change of x is 5 seconds every time. And that's why I changed that to feet per second, because I was measuring every second, not every hour. Okay. So if I kind of figure this, I can do a rectangle, 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 rectangle. Add them together. I got an estimate, right? Estimate. What's the height of each rectangle? I don't know. Let's use the left. Let's assume this. Or let's see. What have I got? Okay. If I use the left side, let's do that one. Left side. What's the height? How far would the left side go up?
Got the velocity number.
Would be the height, 25, yeah. So I would have, length times, I would have 5 times 25, right? Plus, hey, they're all the same width. 5 times, what would be the next one? 31.
Stupid.
And then 5 times the next one. 35. Plus 5 times the next one. So we got 25, 31, 35. There's 3 of them. 43. And another one. Same width, height this time, using the left side is 47. And the last one. Same width of 5, height using the left side, 46. Or what you could do is just do, hey, they're all the same side. Hey, I'm gonna tell you something here. We get very used to pulling the width out front and adding all the heights together. I don't, see, I keep telling you guys, I love tables and graphs because I don't really have to figure a lot of stuff out. I don't have to plug into a formula to get the output. They already told me the output. So usually this is, I'm plugging it into a function every time. I'm plugging a different value of x into a function to get all these y values. I don't need to, okay? I already have all my y values. So then I can just add them all together.
That equals 268. The inside.
The inside,
Yes. Wait, plus 41, right?
nope, because that would be the left side of this rectangle, and I stopped it there.
268.
Yeah, so we're not including that.
41. It's 227.
227,
Yep.
hey, times the common factor I pulled out.
113.
113 what?
5.
1135. And we're looking for distance, and that's feet per second, so there we go. So the distance would be estimated to be. Okay, I started to tell you something and then I forgot. Hey, we get very used to pulling out the common width and then just figuring out the heights. I can guarantee you on the AP, they will give you a table like this, and it will not be the same width every time. They're gonna go from 0 to 5 to 8 to 13 to 15, 19.
Oh.
So you're gonna have to actually do this because it's not gonna be 5, 5, 5, 5, 5. So be very, very careful. Don't worry, we're gonna get some practice. And I'm gonna say, guys, do you notice we don't have the same width? Ah, yes. Yeah, I'm just warning you now, it's gonna happen. Yeah. We can only pull it out if each X width is the same. Well, if we wanted to do the right side, we could probably do the same thing. You can only use the right side of each rectangle. So instead of picking up this side first, I'd pick up that side first, which would be the right side. Wouldn't that be 5? The width is not changing, right? That's not gonna change. So I would have 5 times, oh, but this side is gonna be 31 this time. I'm picking up the right side of the rectangle. And then 5 times 35 would be the next one, plus 5 times 43, plus 5 times 47, plus 5 times 46, 1, 2, 3, 4, 5, there's 6. Plus 5 times. Now, in this case,
We pick up 40.
I would pick up 41, because that's the right side of this one. So now I'm picking up that side, that side, that side, that side, that side, and this side, but not the first one, because that's on the left side.
243 times 5.
Yes, so that would, distance would equal about, pull 5 out, because, hey, look, the widths are all the same.
Why you didn't put the 25? It's left. Why you say it's left?
On the left side, I was picking up the left, I was picking up this one, the left side of the rectangle. If I'm using the right side of the rectangles, I have to pick, I can't pick up this one, what it is 0. This rectangle is gonna go up to 31. And I'll actually use the 41. If I'm using the left side, hey, that's the top of the first rectangle on the left, if I'm using the left side. But then I won't be using that one. So 5 times, you already figured it out, let me write it down so we can see what we're doing.
243.
And that equals 5 times what?
5 times 243.
243 in the middle,
That equals 1215.
1215, and that's distance in feet. So, hey, if I use the left side, I get about 1135 feet is what I've gone. If I use the right side, I do 1215. So, hey, I think distance is somewhere between 1135 and 1215. Hey, what could give me maybe even a little bit closer? Midpoint. Which, you don't want to do that in the table. Because I don't know if the midpoint, like 2.5, is gonna be exactly in between these two values. I don't know that. So you can only use what's in the table, so. If I had a formula, I could figure out what was in between. I don't have a formula, I just have specific readings. So I have to use these numbers, I can't use midpoint. So this would be a Riemann L side, and this would be a Riemann right side, and a Riemann midpoint. We can't do because I don't know if halfway is gonna give me halfway otherwise. Because maybe I was at 25 the whole time, and then all of a sudden I jumped up to 30. Questions? I will tell you, doing this is not hard. It is tedious. It is tedious. Because I think I've got 1 or 2 for you where you have to do it 10 times. Let's do 10 rectangles. And you're just gonna go, are you serious? But notice, I'm gonna go back and sum up what we just did. The distance traveled becomes the area under the velocity function. That may be, I don't know why that keeps, that may be interesting for something in the future. The distance traveled, distance, becomes the area under the graph of the velocity. How are distance and velocity related to each other? Formulaically?
Volume times time.
As
Velocity times time. Distance, right?
if it's constant, yes, but how's the formula for distance or the function for, well, let me put it this way. How is the function for distance and the function for velocity, how are they related to each other?
Velocity is the derivative of everything.
Velocity velocity is the derivative of distance. So that, what does that make distance in terms of velocity? The antiderivative. We're coming back to that antiderivative. We just figured area and we just realized, if I want the antiderivative, maybe I do something that's derivative. I'll leave that worm dangling in the water right now. That's it. You guys just need practice. You just need practice.